presenter is David Schaff, who I used to work with at Temple University, and now this is a study with a multi-university group of colleagues, and I don't know much more about it, so I'm going to give it some time.
That's I guess, what I'm here for. So yes, and so I'm going to talk to you today about a project that's very new. We don't have data. We haven't run the experiment yet. So it's also we have a version of this that we're presenting at a different conference a little bit later that talks more about the conceptual theoretical side. Thought I would spend some time today giving you an overview of that, what the basic idea is, but spending a little more time on the experimental design itself and get some feedback about that. So the premise of this project is that we are trying to find ways to get non-technical managers to build analytical models, to make better use of this thing called self-service business intelligence. And so a lot of the self-service business intelligence has been around reporting. What we're trying to do is figure out how we can extend that into model building. And so to set the stage for that, we have this quote, all models are wrong, but some are useful, which is a very well-known quote about modeling. And really what that gets to is sort of the unstructured, ambiguous nature of building a good analytical model. And so because it's difficult to do, and because it's got some inherent ambiguity, what you need is a team of people to do that. You need people from the business side, you need data scientists, you need the IT group, all working together, and it becomes a very expensive proposition to have a really good analytics team. And it kind of flies in the face of this idea that we've been hearing lately about the democratization of analytics. That what we want to do is we want to bring analytics capability to the people. And I'll show you an example of a tool that's supposed to do that, but we're arguing it doesn't really, and then we'll give you an alternative. So we also cite these two statistics, that 52% of managers want to be able to do this type of self-service model building without the aid of an IT group, and without the aid of a data scientist. 22% have access to those tools. And I would say, and there was no number on this, but it's a good deal lower people that can actually produce useful things from it. So it's a relatively small group that can do this on their own. So managers building models on their own isn't a new idea. And in fact, here's a list of previous model management efforts, model building efforts. And a lot of those have been around building grammars and building syntax for a modeling language that somebody who does not have a lot of statistical background can do, and then hand over to your technical people. And there's a bunch of these, and so I can talk about the one in the middle because I was co-author on it, so like a million years ago. But what it basically did was it said that all of the sigmas that you see in mathematical models are very confusing for people, so what we're going to do is we're going to create a grammar, a syntax around how to express that in a very simple way that anybody can understand. So the managers can read the models and the managers can build the models. However, even despite all of this development, models still are difficult for people to build and expensive for people to build. And so, why were these even developed in the first place? There's two things. First of all, it's not that, this is from Jeffrey, but it's not that MSOR is a low value activity. It's that if you're a manager, you want to be able to hand that off to somebody else, but also managers are reluctant to ask for this kind of assistance. So that's what kind of inspired these, but we still have these problems. So despite the 80s and 90s where these were really popular, it just kind of died off, this whole model building language. So why did they fail? Well, they failed for a couple reasons. One was because these modeling languages tend to focus on deterministic models. And also because it makes an inherent assumption that the modeler knows what variables to include. It makes some inherent assumption that they know what they're doing. And if you don't have, and they assume that, and it also assumes that I know what kind of statistical technique to use, and what kind of transformation to use. So that's really not And so, I can keep talking. So, if you think about what most analytics problems are, they deal with semi-structured and unstructured problems. So it's not well suited for what a lot of these modeling languages were able to help you do. There's an analogy to this to visual programming. So if you think about the effort to bring programming to the people, you had Power Builder, you had Visual Studio, there's this thing called Blocky, I don't know if you're familiar with that. That's where you've got these little puzzle pieces that you can attach directions to, and you attach and you sort of string them along, and it generates code for you. Analogous to that, there is a growing trend to have visual modeling tools. So if you've used SAS Enterprise Miner, if you use an SPSS modeler, they look something like this. They don't look like that.
Sorry,
That would be the one slide where I need you to actually see the slide. Boom. There we go. That's cool. So this is something I actually use in my class, SAS Enterprise Miner. So you might have seen this before. This is their Java-based interface for it. And what you do is you drag and drop a series of nodes, and those nodes perform different actions. So this makes the software a lot easier to use. What it's really doing is generating the SAS code behind the scenes and doing that part for you. But really all it does is make using the software easier. It doesn't make you a better modeler. So just like Microsoft Visual Studio doesn't make you a better programmer, this doesn't make you a better modeler. It just, if you know what you're modeling, it makes it easier to do. I have to know less SAS, not less about modeling. So tools that we really want to take us to the next level of this self-service idea need to really support decision making. They can't just make it easier once you've made all the decisions. So we need to go back a stage. So we talk about the self-service analytics, and so what are the requirements of that? Well, you really want to be able to do four things. You want to be able to identify the relevant variables, identify the relationships between those variables. You have to have some way of assessing how useful the model is that you've created. And then you have to determine where to stop spending effort. So this actually fits in really nicely with this design science idea of a wicked problem, something that's sort of inherently unstructured, doesn't have a clear solution, the parameters aren't always well known, but it's exactly the kind of thing that makes it hard for people who don't have a lot of experience with it to do it. So our efforts are, we create a tool that facilitates this. So from a theoretical perspective, so this is a little bit of theory that I left in this, is we incorporated this idea of cognitive feed forward. So all cognitive feed forward says is, I'm going to tell you about how good a potential solution is before you do it. So it's not feedback where I do something and it says you were 85% accurate. It says here are the options and here are the trade-offs between the choices. So here's how, if you pick these variables from the regression model in the past, here's what it did to the R squared, something like that. So the idea is, can I give you and can I embed information and give it to you on the front end and help you make a better decision about the model you're going to create. So cognitive feed forward is the concept that we've based this on. So then what we did is we took this thing called SAS SEMO. So if you're familiar with that, that's this methodology that SAS has for building models that's basically, what is it? I forget the S. I wrote it down. Wait a minute. Sample, explore, modify, model, assess. So basically what it does is, you look at the data, you look at the available data, you look at the relationships of the data, kind of like what we were talking about, and then you create the model and then you assess it. So what we did was we modified that basic process to create a structured methodology for model formulation that this tool is going to be based on. And if you look at it, it follows that basic premise. You define the problem, you figure out we want something that's going to help you determine hypothesized relationships, we want something that's going to help you determine what data you need. And then what we really want here is to give us some set of candidate models so we can pick which one serves us the best. So what do we need to identify? If you're a modeler, whether or not you're an expert, you need to know what the domain is, what you're trying to predict, what the predictors are, what techniques are available, what transformations are available, And perhaps most importantly, what measures of success there are. Yes?
I can't see, a person who's not knowledgeable enough about, modeling to be able to use that. It's like, you go to an airport and the system takes care of the check-in process. And then, if the system fails, they know how to check you in manually. So it's like, using something like this as if you are talking to a knowledgeable colleague and then, exchanging ideas. So you still need the knowledge of model building if this doesn't.
So yeah, and so that's sort of the challenge of this, right? That's what we're trying to remedy. And so I'll show you how we're thinking about doing it, and we can see how, part of why I'm presenting this is to get feedback about what we could do differently. But yeah, but that's really the challenge, right? Because is there some amount of information that I can give you, or give a novice, right, who is going to be, that will cue them enough to build the model? So
can you give this to my 11-year-old son and,
So
make him build models?
So the idea is, if your 11-year-old son was familiar with the business domain, right, then the idea would be to get to a point where they could, because what they would do is they would see some number, and they could pick the highest number.
Hockey, maybe.
Yeah. So if it was about hockey, we would be okay, right? So let me show you what we're talking about here. There's a couple pieces to it. The first piece is we designed a dimensional warehouse. So this is the star schema for a warehouse to support model formulation. And all that means is, what we did was we took these things and we made them dimensions. And so the idea is you store in a database the collection of models that an organization has used and their past success with them. So where does success go? It goes in the effectiveness measure. And so if you know anything about about dimensional modeling and the star schema, is when you take this collection of dimensions together, what they basically do is they get joined and you have a single line, and that line is a collection of, becomes a collection of models. So the power of this is I can constrain on any one of these the things I do know, and I can see my options for the things that I don't know. So it's like if I constrained on subject and predicted, it's like, well, here's my outcome, I could see all of the potential predictors that people used for that. And then for all those potential combinations of predictors, I could see what the effectiveness measure was. So maybe this combination would be 68% and that combination would be 92%. And what number is measured by 68 and 92, that would be determined based on what was relevant for that technique. So it gives me a way for a modeler to search based on what they do know to find options for what they don't know. So where we were going to test this, and I'm going to get into the experiment a little bit, is profiling for unemployment insurance. What we are going to do is look at who exhausts benefit. Can people identify who are going to exhaust their unemployment benefits without counseling? So where do we need to intervene and where can we just hang back and they'll figure out how to find a job before they run out of benefits? So the subject is profiling. That would be our subject domain. Our outcome variable is the probability that a claimant exhausts. And what I want to do is I want to get my predictive, my ability to predict as high as I can. And what I could do is if I constrained on these, using that database, I could see a list of previously used predictors, techniques, transformations, effectiveness measures. So predictors might be agent education, techniques might be logit model, decision tree model, the transformation might be logs or power functions. And so there's several effectiveness measures. So the idea is that this just, this becomes a knowledge repository, but it's structured in a way to facilitate decision making by telling people what models people have used, and then in advance telling them what the historical accuracy of those models has been. So it tells people who might not know what to pick, at least they know their options. So, and if I really don't know what I'm doing, and I'm picking relatively blindly, at least what I can do is I can start comparing effectiveness measures. So the experiment itself that we're talking about doing. So we have access to analysts, to 53 analysts at the US Department of Labor. The treatment will be, we're going to create a interface for this dimensional warehouse. And so this is just a very simple example that we dashed off. The one we're envisioning is going to be more complex and interesting than this. But what this does is, this just does a very simple pivot table on the warehouse that says, okay, binary exhaust basically says, do you exhaust your benefits or not? That's the outcome. And here are all of the input variables, predictors. And here's how often they get used. So this just tells you how popular are these different variables. Now, this is just one way of looking at it. What's probably a more useful thing to do is to also have another column here that says, well, here's the aggregate effectiveness measures. And you might even get down to saying, well, for this technique, for this technique and this set of variables, if you use technique A, you get this level of effectiveness, technique B, you get that level of effectiveness. Does that make sense? So the design of the experiment is we would have our control group would be the unstructured information in a warehouse. So what that means is we give you a set of documents, which is what they have now, on prior modeling. Just like a guide to modeling, and a guide to what all the variables mean. And there's actually 71 candidate variables that these people have access to as they try to build a better model. So we say, here's the model, here's a big document with all the model, with all the potential variables in it, and here's all your choices, go. What we give to the treatment group is we give them that information, but we also give them the warehouse and an interface to be able to make better choices, to see if they can use that effectively to improve the job that they do. So the data set they have will be the 71 candidate variables that predict exhaust. And what we're going to say is build a model. That's the task, is build a model and then come back to us. And so how we're going to evaluate it is, first of all, just on correctness. So do they get the different pieces of the model right? Did they build a plausible model? This gets to your point, is are they going to be able to build something that works? Then, and the other thing they can do when you look at correctness is you can also look at, did they pick the one that gets you to the highest possible metric? We're also going to look at satisfaction from a user perspective. There's a bunch of different ways to measure satisfaction. And so I refer to this Stallone and McLean, which talks about different ways of measuring it. We're not quite sure exactly, we could just ask them flat out, but then we can also get at some more nuanced ways of looking at that. We're also talking about looking at cognitive effort. So what's probably more important than satisfaction, related to satisfaction, is cognitive effort. So can we lower their cognitive effort while maintaining and getting them to a higher level of correctness? And so again, this RSME is just a measure of just a cognitive effort scale. It goes from 0 to 100, and you tick off a little box that tells you where you were on that scale. So it's a very simple way of measuring cognitive effort. So what we are looking at is for the treatment group to outperform the control group on correctness, to pick a better model than they would otherwise pick. On satisfaction, are they going to be more satisfied with the process? And then finally, are they going to be able to do this with lower cognitive effort? I think I might have made one more slide. I did. So we can. Yes. Something like that. So what we think the contributions of this will be is the basic thing is we're developing a new tool to support this sort of the next phase of this self-service business intelligence. Can we get people to build models and not just do reporting? We want to do some, even that went away? We want to do some empirical validation on this tool. we want to do some empirical validation on the tool and look specifically at the theoretical mechanism of feed forward and see how that informs it. And we can also play around with different types of feed forward. We could compare it to feedback, although there's already studies that show that for this type of thing, cognitive feed forward should be the best thing, but we could verify that. And then finally, it's a novel use of dimensional modeling to support a business problem that's not just aggregating sales, right? It goes beyond what a lot of warehouses are used for, and comes up with another way that dimensional models can help people make decisions. There's another example of this that one of my co-authors and I have forthcoming, it's the same group of people actually is on this, that looks at creating a dimensional model for facilitating document retrieval. So, which is actually how we got the idea for this, is we were looking at, can you build a document warehouse where you can constrain on certain dimensions and very easily zero in on a document. This is, can we constrain on different aspects of a model and zero in on a specific model. So it's, in a way, it's an extension to that. So, that's what I got. Thank you very much. Any questions?
David,
Yes.
a couple quick questions. You started talking about managers, but it seems it's the target audience is more analysts. Am I right?
Actually, yes, that's a good point. For the experiment, we're using analysts, and some of that is because that's who we have access to.
Right.
But this should work for managers. What we're doing here, in some ways, they're not that different because the analysts are not going to have enormous technical knowledge of the statistics, because that's what basically this we're looking at. It's in the context of being trained to be able to create these models. So these are kind of like pre-knowledge analysts. But I guess what we would want to do beyond this is see if we could replicate this with managers that we could get access to.
So
Because they would have even less expertise.
Exactly. So a couple of quick things. I mean, I do a lot of work with both communities on the same issues, and it strikes me that the mind share that a manager has to think about modeling is about this big relative to the analyst.
Yep.
Okay, so you've probably seen what Rapid Miner has done.
Yes.
And there is analytics and it can the Eureka models and stuff like that. So those seem to be more on the manager side than the analyst side, because they're not trying to turn them into model builders.
Right.
They're trying to turn them into consumers of models rather than having them actually try to build it. So with the analyst community, you know, that might work out because they have some concept of dimensional modeling somewhere. The manager, you talk to a manager about dimensional modeling. Oh yeah, it's like back to the 60s.
Well, they should, and this doesn't directly address your Rapid Miner point, but the dimensional modeling piece is you wouldn't actually give them the dimensional model.
Right.
What you do is you give them an interface that basically hides the complexity.
Okay.
So they wouldn't need to understand. Yeah, I mean, if you're saying we're going to make your life easier by not having to build a model, and so here's a star scheme that you don't know how it works, and go and use that.
So they just drag and drop.
And so it would be some drag and drop type of interface. Now, whether or not, how it compares to what they can get on Rapid Miner is another issue.
Yeah, it's an infrastructure conversation more than anything else.
Yeah.
Because if you build a dimensional model that supports them dragging and dropping on the front end, then right?
Yeah, and so in fact, the something that I don't have time to discuss, but I'll tell you in 30 seconds. So where this eventually would go is you can see this fitting into an architecture, that you've got this sitting here and then you've got SAS over here. And once you pick the model, it generates the code for you. So that's really the eventual place that this is going. And what this is supposed to do that some of the other things that generate code don't do is it facilitates that initial selection in a way that those things we don't believe do. Questions? Yes.
So you are trying to build this interface, but are you taking into consideration all the aspects, all the different problems that we are seeing right now in real time? Right. So what feels to me is that these are mostly the regression and other kind of models, but are you actually considering into fitting in other type of problem statements, like statement analysis,
Sure.
mining, OR applications?
You should be able to. So as long as you know what the outcome variable is, and as long as you have an outcome variable and predictors, this thing would work for that in whatever, and your outcome variable could be, some categorization, right? So as long as you have like an input and an output, you should be able to use this. A lot of this, like this example, is a very regression-y type of example, but it should be applicable beyond that. Now, whether or not this was designed too much with those models in mind, whether or not the structure of the underlying database might have to be a little more flexible, that might be something that we would do.
But most of the real-time problems require a lot of data creation itself.
You mean like they don't even have the data?
Yeah, so the managers will not be having the data in the form that they
Right.
might consume. So it might be far more complex in nature. Does this technique also account for those?
That's a good point. I'm not sure that this would address that. I'm not sure this would address if you don't have if you don't even have the data, right? Because what it could do is help you see what has been done before and get an idea about what's possible. But but it's not something that you can feed in. Here's what I want to do, and here's what the outcome is. It's more of, I've got all of this stuff. How do I make sense of it and build a model from it? So it does assume that it doesn't assume that you know what goes where, but it assumes that you have this set of things that's already there. So, the ultimate goal of this is not to completely remove data scientists from the process, just like visual programming languages aren't supposed to remove hardcore programmers from it. What it's supposed to do is take a piece of what the data scientists would do normally and offload it. So some of the problems, as they get more complicated, you might still have to have people doing those, other people doing those, but at least this set we can start moving it. So it's to simplify. Questions? Yes?
Follow up on that, I can see that you see it as a very useful repository, handover and maintaining appropriate knowledge and all of that, but the need to introduce and build and maintain the warehouse is non-trivial. There will be new things, there will be new models, there will be new questions.
Right.
And often we find in the interaction with the decision makers that the original decisions and thinkers coordinated exactly when you tease it out. It's more complex than that.
Yeah, I think there's two separate things there, right? There's the maintenance piece of it, which is always a problem. Part of that document paper that we did was to show that spending the effort up front is worth it because you get benefits later, and sometimes it's still hard to convince people that it is. As far as the open-ended imagining of things, which I think is your other point, is how do you know? What it allows you to do is look at what was done before, right? If there's something that hasn't been done before, it wouldn't be captured by this necessarily, right? But that's not really the purpose of it. So in some sense, this is scope, right? It becomes sort of a knowledge base. So for the stuff that you're talking about, you could still have a staff of people or consultants that you would bring in to do that. But going to the same group in order to build the same types of models to solve the same or similar problems, this is supposed to help with that. So.
And you would have folks to add to it.
And you would need you would need people to add to it, and you would probably need some sort of technical people to add to it, or they wouldn't be able to add to it properly because the integrity of the data is important. Now, could you build tools that facilitated that, made it simpler? I'm sure you